Is this working? Oh, okay, good. Okay. So back to what are we doing? We're doing the decision tree. That's still running. So valid classifiers, we're going to add to that the decision tree classifier. Okay, then here let's say elif self.classifier type is equal to decision tree. What we're going to do, let's zoom out of here. All right, so if we're looking at a decision tree, we want to get that decision tree classifier. Oops. So from sklearn.tree import decision tree classifier. From sklearn.tree import decision tree classifier. All right. Oh, it's a class, so it's in caps. It's in upper camel case. Decision tree classifier. Okay, now what's that look like? Decision tree classifier, max depth equals 5, random state equals 42. Okay, so back down here, if we're trying to get to our decision tree classifier, self.clf is equal to decision tree classifier of, and we'll just use the same thing, max depth is equal to 5, random state is equal to 42. Okay. Now, decision tree classifier, that should be all we have to do. Let's go see if the Gaussian process is still running. Whoa. Okay. So it's printing something, 92 minus 128. Okay, let's look for our print statements to see what it's printing there. So print win of 0, win of 1. So that's the probability. Oh. So we probably want a different threshold. Test classifier. Test seasons. Test classifier years. Test classifiers true than. Okay, so I guess the classifier years we can make it go quicker by just doing this on 2021, and then we need to change the tolerance. This could just be, say, 10. And then we want to change the tolerance. So that's up here in our classifier class, test classifier, tolerance, oh, placement threshold. Now these, I mean, it's not really sure about a lot of these. So maybe we could just say 70% as placement threshold. 0.7. And let's make sure this is saved. Cool. My seasons np.a range. Forgot the comma. Oh, and we do want to see the plot so we know if it looks good or not. And then maybe if different classifiers show that they're good at different things, we could combine them and use both at once. Class test, no mirrors to train on, my seasons. Okay, so this doesn't look very good. This is classifying everything as a win, it looks like. Um, oh no, there's some lighter regions in there. Oh, I guess it was saying everything's a loss, not a win. Oh, and that's actually pretty good. Because that's saying, like, if something falls in here, take it. If it falls in here, take it. Yeah, so now how to make add a color map plot to, what is this thing called? Um, Plot decision boundary display, decision boundary display, show color map. Because I want to see what the scale is we're looking at as we look at it. Um, uh, how do we show the color map on there? PLT dot, Changing color in scikit's example for plotting decision boundaries of a voting classifier. The colors are chosen to the values. Z has 3 levels as well. Their color. Yeah, but I want to see the color map. Okay. Plot color map. Matplotlib. Okay, whatever. So, all right. Now that's our color map. Now what are the results we get? What's it doing? Still running? Oh, there's 2. That second plot window. Nice. So if we changed the threshold around for the Gaussian process, that improves it and it works on 10 years of training data. But it runs kind of slow. We want to see how it does looking back for some number of years. So we could run that again. Okay, we should add an item to the Trello board. It says figure out how to make it work. So in to-dos, optimize, perform full test on Gaussian process and tweak. What is that thing we're looking at? Oops, sorry, buddy. Um, so perform full test on Gaussian process and tweak placement threshold to get the best returns. So optimize. So now we could add another function called optimize Gaussian process. Um, and we're just gonna say pass because we actually don't want to do that right now. Now, um, for we just actually want to look at the Gaussian process. Test classifier years to look back. Okay, so we're testing on the last 10 years. Okay, we do want to plot, or we don't want to plot. Um, but we want to get all years from 2007 through 2022, and we should probably only do 5 years of training data. For your and my seasons. Okay, now we need 5, so let's go look at what this is like if we mess with this. So Python 3, we're gonna say what it says here. My seasons is equal to, let's import numpy as np. Okay, ms is equal to np.arange 2007 to 2022, then turn it into a list. Now ms of 5 till, so what we want to do is cut off the first 5 years, so 7, 8, 9, 10, 11. So basically get 2012 onward. Nice. So then we could say my seasons is equal to num years to train on colon. Oh, well, my seasons equal to my seasons of num years to train on colon. All right, now exit out of here and so we're gonna try the Gaussian test on 5 training years. Okay, save, and then let's run it. This is gonna take quite a while to run. 2007 to 2022, yeah, nice. Um, okay, so we've got the Gaussian process. Let's go add. What do we want to add? Oh, we've added the decision tree classifier. Yeah, so now let's go try the same thing, except instead of Gaussian process, let's do decision tree. And let's see if the decision tree performs any better. Okay, now Python 3, analysis1.py, and that should run the decision tree classifier on our data. And that might be faster than the Gaussian process. I hope it is. All right, now, Oh, random forest would be good, but I think random forest probably takes a long time. But you also get random, the decision tree classifier, you don't get as much uncertainty. Random forest, you get nice uncertainty in there, but it still doesn't fit it that well. The neural net seems to work really well. Hmm. Hey. Oh, sorry, buddy. All right. Now, what do we want to implement next? I guess the neural net would be nice. Um, so what did that look like? MLPC classifier. So classifier names for names, CLF zip names, classifiers, names. Oh, neural net is 1, 2, 3, 4 from the bottom. 1, 2, 3, 4. Oh, MLPC classifier. Okay. So let's do what they have there from sklearn.neural network. From sklearn.neural network import MLPC. Oh, MLP classifier, duh. Machine learning process classifier. I see. Okay, take this back down here. And then we're gonna say in our valid classifier types, we're gonna add neural net. Now, oh, this one's already finished. And negative returns for several years. Our Gaussian process finished as well. Gaussian process got negative for a few years, but seems to do really well post 2014, which is markedly different from the triangle method. And that makes me wonder if we could combine the triangle method and the Gaussian process. So we could also use a different threshold, but let's just increase the training years real quick and see how that works for us. So what if we make it train on 8 years of data? What does that look like? So 8 years of data. Let's run it again. Oh no, we don't want that. So both of these are running decision trees. This one we should run as a Gaussian process. So now we flip. The second one's Gaussian process, first one's decision tree. Okay, now let's go run that. Okay, so this is the decision tree. Nice, so decision tree already finished. Return negative for 2015, but positive otherwise. I wonder what the decision tree plot looks like. No. So if we increase the years it trains on, decision tree does better, but still gets negative for 1 year. I want to see if Gaussian process does well. Okay, let's finish implementing the neural net. So, oh yeah, Did I already? Yeah, okay, good. Um, okay, decision tree, and then we could say elif self dot classifier type is equal to um, if classifier type is a neural net, then we're going to want to do whatever we done here with machine learning process classifier. So self .clf is equal to MLP classifier. And the arguments will be alpha is equal to 1, max iterations is equal to 1,000, random state is equal to 42. Okay, now that seems to work. Now we could go down here and say do it on the neural net. Okay, so oh, this is still the decision tree. Gaussian process is still running. So now it's running on a neural net. Let's change this to just go back to 5 years and let's run it. Okay, so the neural net actually might take a substantial amount of time. So we could forget about that for now. Now, what are the other things we want? Naive Bayes would be good. So naive Bayes, what? Actually, we want things where the data is kind of clustered together. There's a lot of areas where the data is together. It's not really separated too much. So maybe here, maybe the first two, things that perform well on the first two. Nearest neighbors actually does really well. Random forest does well too on that top data, but not so great on the middle data. All right, let's add random forest and naive Bayes. Okay, neural net. Random forest. And then here, naive Bayes. And then naive Bayes is Gaussian NB. Gaussian NB from sklearn.naive Bayes, import Gaussian.nb. From sklearn.naive Bayes, import Gaussian NB. Okay, so once we have the two, oh, we want both of these. So we don't want just naive Bayes, we also want, what was that one we're looking for? Adaboo's, decision tree classifier, random forest classifier, random forest. From sklearn, dot ensemble import random forest classifier. All right, now we've got that. Now, when we actually have the random forest classifier in here, how do we want to define it? Um, okay, so let's check on these real quick. Okay, this was the Gaussian process, and the Gaussian process works. For 8 years, it only returns positive, which is good. Okay, so let's start documenting this, putting it in the PowerPoint. Okay, now Gaussian process classifier training on variable years. And this is the first one. Shrink that a little bit. And then we could put a text box in. Where is that? We have our screenshot, so let's do Gaussian process a second time. All right. And last time we did it on 10 years. 10 years? Yeah, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, so 2015 only trained on 9 years? For a year in my seasons equals my season of number of years to train on. Man, that's annoying. So let's go try that thing again. Python 3. Import numpy as np. np dot arange 2007 to 2022 dot to list. Okay, then let's just get 5 till. So 2007, 8, 9, 10, 11. Yeah, so if we're starting with those 7, 7, 8, 9, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the first year should be 2017. Oh, unless I was doing it on 8 years to train on. I do think that's what I was doing. So let's do 6 years to train on. Gaussian process. Okay. Oh man, was this the neural net or the Gaussian process? Refresh this. All right, classifier results. Now what did the neural net do? It gave us negative the first 3 years, but then after that it gave us positive. Not sure what to make of that. 0.1934. Huh. All right. Neural net results doesn't look as good as the Gaussian process, so I'm going to keep focusing on the Gaussian process for now. Okay. That's going to run Gaussian process, looking back 6 years, and tell us how it does. Let's go back here and document what we have. Just need a text box. Right. There was a good text box I put in somewhere. Don't know where it is now. Okay, whatever. Just put that thing in. So this is going back 8 years. Okay, nice. Okay, so let's implement our other classifiers real quick. Check on there to make sure I'm not missing any chats. So the other classifiers we added naive Bayes and stuff. Now let's go up to the valid classifiers list. Have all that. MLPC classifier, so we just need to add the random forest and naive Bayes. So if classifier self.classifier type, self.classifier type is equal to naive Bayes, then let's go ahead and do self.clf is equal to Gaussian and B. Okay, that was easy. And then the last one, if self.classifier type is equal to not naive Bayes, but now if it's equal to random forest, then we're going to go ahead and do our random forest code. Self.clf is equal to random forest classifier max depth. Let's just copy all that stuff. Okay, self.clf is this. Whoops. What? All right, nice. Okay, so we've implemented our other classifiers. Now let's just try naive Bayes and random forest. So let's see, is the Gaussian done yet? Nope. So this one we could say do it on naive Bayes. All right, now let's run it and see how it does. Gaussian process is still going. So now let's go to our Trello board and let's see what we want to do moving forward because we've implemented these classifiers. Determine one or few best performing classifiers and hone/tweak results to get a robust technique. All right, now let's move this into to do because we're not doing that today. Try to get positive results for all seasons. Okay, now we've generalized the classifier. So we can move this to done. Okay. Now I'm just gonna wait for the, whoa, oh, that was naive Bayes. So naive Bayes performs poorly, but we might need to tweak that parameter. Gaussian process training on the previous 6 years returns positive for every year except one. So let's document that. And we could add it to the PowerPoint for 6 years of training on a Gaussian process. Okay, so here's 8 years. 6 years. 6 años. Okay, so now I'm going to go back and get this for every year, every number of training years. And if we find that it just performs for this number of years and beyond, then it will be a robust technique. And the thing to do from there will be to optimize for total returns over time based on optimize that threshold value to get total returns over time. So thanks for watching. That's all for this stream. See you again tomorrow. Good. No one's watching, so one person watched for